This guide will show the assembly of the EMF meter, which is a working replica of the one shown in the Supernatural TV series. There are a number of build options depending on the style of replica you want to make, as well as component availability. These will be mentioned throughout the video. This meter can also be built as a prop only by not populating the analog portion of the schematic. This is part 1 and covers the PCB assembly. Check out part 2 for installing the VU meter, coils, antennas, fake wiring, and power options. Before we start, let's talk about some supplies you will need. I find a medium diameter solder works well for the through-hole parts. I'm using some 34mm or 0.87mm rosin flux core 6040 solder. Wire cutters that can cut flush to the surface are needed to trim the wire leads. As I mentioned, the solder I use has a flux core, but sometimes it can be useful to have some extra flux available. For cleaning up excess solder, some solder braid can be useful. This is a medium braid, about 0.05 inches. A set of tweezers can be useful for the small parts, and a narrow soldering iron tip as well. If you are just starting to learn soldering, try using heat sinks on the sensitive parts like ICs and diodes. And finally, some hot glue will be needed for the final assembly in part 2. Also, some of these parts can be ESD sensitive, so use proper care. So let's get started. The majority of the components will be mounted on the back of the board and are all through-hole parts except for the 5-volt voltage regulator. I usually start with the larger ICs and work toward the outside of the circuit board, but any method you choose will work. Just make sure you have enough working area around the parts you are applying, and note the pin 1 markings on each IC so it matches the PCB stencil. Also note that U2, R18, R21 must be installed before U3. Since this is a replica of the EMF meter from the TV series, I've placed the majority of the parts under the VU meter. To allow the meter to sit flush with the circuit board, you will need to test fit the ICs and clip the leads flush with the top of the board. Then remove the part and clip a bit more from each lead. I'm starting with installing U5. I'll clip the leads flush with the top side of the board and then remove the IC to clip a bit more. I'll then reinstall it to check that there are no bits poking through. I'll do this same procedure for all parts: ICs, resistors, caps, diodes, etc. If it looks good, I can solder it in. I'm also soldering all parts from the back side of the PCB. Repetitive video will speed up to shorten the time. Review the solder joints and move on to the next part. I'm now installing U1 just like I did with U5. Check the part orientation and solder it in. Check the solder connections and touch up any bad spots. Now to install the parts that will be under U3. This will be U2, R18, and R21. It will be easier to program U3 now if you have not already done so. There is also an ICSP programming port, so it can be reprogrammed later if needed. For the resistors, check the leads just like the ICs. Go ahead and clean up any flux with some isopropyl alcohol before installing U3. Check the height of U3 so it sits over the previously installed components. Height should not be greater than 10 millimeters to allow spacing for the standoffs and battery packs. clean up any residual flux. Now moving on to the remaining components, starting with the resistors. I'll usually start at the top and work my way around the board. I found it helpful to have a bending guide for the resistors and diodes, so I printed a 3D part to do so. The bottom edge was also a perfect height to cut the leads. As you're installing these parts, check the top of the board to make sure the leads do not poke through. I'm now installing all the capacitors. Most will be on the back side of the board, but two, C7 and C16, will mount on the front. For the electrolytics, make sure you install with the correct polarity and lay them as flat as possible on the board to keep that clearance under 10 millimeters so the battery packs can be mounted. For some of the smaller caps, you may need to solder them in from the top of the board. Since I'm in the area, I took care of JP1. This solder pad is for programming U2, the ATtiny85, and allows the ICSP port to power the ATtiny, or you can just use the main battery power. Pins 1 and 2 must be jumpered together for actual operation. Continue to install the remaining mylar and ceramic caps on the bottom and keep them as flat as possible. As mentioned, two caps are installed on top, C7 and C16. C7 should be a blue color and C16 will be black to match those in the series prop. There's a small plus on the top silk screen to indicate polarity. I'm installing the diodes next. Make sure the cathode line of the diode matches the silk screen of the PCB. You can now install a 5-volt regulator. If you are using AA batteries, you will need to use an LDO or low dropout type regulator. Time to decide on JP2 and solder either bar or dot display mode. Install the dip switch or piano switch to the bottom PCB. Install the 3 push-button switches for volume and test functions. Moving back to the top of the board, I'm installing the variable resistors RV1 through RV3. This board will support a variety of resistors, the 3326 and the 3386 for the small blue ones, and either the PT10, PT15, or generic for the other. Installing the EECO rotary switch. These can be hard to find, so the board supports a variety of configurations. It also has jumpers on the bottom to make different circuit connections. You can now install the 4 or 5 fake capacitors. These are for visuals only to match the series prop. The top of the board shows the cap color and location. The silkscreen will be hidden under the part once it's installed. There is an additional pad for the top hole, so a longer cap can be used if needed. If you decide to install the 5th cap, the location is marked on the PCB bottom, but install it on the top. Test fit the power switch. Some of the leads may need to be realigned to fit the footprint. Solder and clip the leads. LEDs are installed so they are just flush with the edge of the board. You can install on the top or the bottom of the board, as the wires will not be seen once the black tape is added. A line by one of the bottom pads marks the cathode or negative wire. Coil L2 is a non-functional cosmetic part. The coil was made using some 22 gauge plain copper wire wrapped around a number 2 Craftsman Phillips screwdriver shaft to get about a 6.4 millimeter diameter coil. The coil should be the length of the meter, or about 1 3/4 inches. There are 2 top holes that can be used for L2. This allows the coil to be longer or stretched if needed. If it looks like any wires might short against the coil, trim them as short as possible and put a small dab of hot glue on them and the coil to secure and insulate it. This completes part 1 of the EMF meter assembly. Please check out part 2 to continue this guide. Please check out the links in the video description for purchasing either blank circuit boards or assembled meters, and you can check out my GitHub for a detailed assembly user guide, schematic, and 3D part files.